is during the process of going through the webinar, feel free to ask questions in the chat window, and each one of the presenters is going to remind you about that during the course, because we really want to make this a very interactive webinar. So with that, I'm going to turn it over to Dennis, who's going to start off and talk all about the value proposition and what's going on in the world of ISA95. And then Paul Hunker will tell you about OPC UA. And then Rich Kane will actually, who from Capstone Technology, talk about the real product and how this actually works. Go ahead, Dennis.
Okay, well, thank you, Tom. My name is Dennis Brandel. I'm a consultant in the area of manufacturing IT and using IT solutions in production companies. But for purposes of today's discussion, I am also one of the authors and the editor of the ISA95 standard, and I've also helped to develop the OPC UA ISA95 specification. I've been involved in this work on the ISA95 standard for about 20 years, which is an extremely long period of time, I think, for something like this to have been in development and still be extremely relevant to what's going on. So I'll be explaining a little bit about what ISA95 is, an overview of it, and how it fits in and where OPC fits into the ISA95 model and the advantages that you get from applying it there. Paul?
Yeah, I'm Paul Hunker. I'm an editor on the OPC Foundation's UA working group, so I manage a number of the specifications as editor. I'm also chairman of the ISA95 UA working group. I've been working on OPC for pretty much since it started, first with Classic and then with OPC UA. I'm an independent consultant, so I earn my living teaching people about OPC UA and about OPC in general. With that, I'll let Rich introduce himself briefly with a little summary of him.
Hi, Rich Kane from Capstone Technology. I'm an architect on this project and developer, and I've been working on UA for a couple of years now. Prior to Capstone, I was with manufacturing for 25 years in engineering and IT. Back to you, Paul.
All right, I think Dennis is going to start off with 95. Thank you.
Okay, this is just a brief overview for those of you who are not familiar with ISA95. And if you've been heavily involved in the areas of PLCs and DCS systems, you might not be aware of all the activities that have been going on in the ISA95 and the associated IEC standards. And these activities really deal with all those things that occur above the PLC, DCS, basic control, advanced control systems, and the business level systems that are really driving plant schedules and those sort of activities. The standards have been in development actually since 1995. The latest versions of them, as you can see on here, came out in 2010, 2013. We have just finished Part 6, which is actually coming, which will probably be dated 2015. We have Part 7 coming out as well. So there is work going on, and there's continual evolution of this work going on because people have found this to be extremely valuable. It's also available in the IEC standard as IEC 62264. So it's not just a USA ANSI standard, but it's also an international standard. Now, the standard, the ISA95, again, as a brief summary for those of you not familiar with it, has defined a set of levels. These definitions really relate to the things that go on, the activities that go on inside a manufacturing company, dealing all the way from the business level systems, which is up at level 4, where you establish the basic plant schedule. You make sure that materials will be available at the plant or at the site, and that there'll be transportation to take the materials away that you finally produce, all the way down to level 0. Level 0 is the physical production process, the actual chemistry or physics that's going on that's producing the product itself. Level 1 systems are those systems that do the sensing and the manipulation of the physical process, maybe no more than a wet stick inside a tank to find the inventory, or it could be a full radar level detector on the tank and anything that falls in between. Level 2 systems tend to be those that are the PLCs and DCS control systems. They perform the advanced control, the basic control, the on-off control, safety interlock, and these other things. Level 3, which is the ones that the ISA95 deals with, deal with workflows and recipe management, the control of the materials, the people, and the inventory as it moves through all of the equipment inside the facilities. The reason that these levels show up tends to do a lot with skill sets. Level 1, people skilled in level 1 are the technicians who understand the instruments and the sensors. Level 2 are those people that do the basic control and the advanced control, the PLC, the DCS control. Level 3 are people who tend to be a little bit more IT focused and deal with the recipes, the workflows, the data historians, and the other things that go on above the basic control systems. Level 4 tend to be business people and straight IT people. Different sets of skills. That's part of the reason that we have some of these levels that are in here. Now, what ISA95 does is it defines the interfaces between these different levels, between level 4 and level 3, and within the level 3, because in level 3 there's these collection, maybe 50 to 100 different applications in any given facility, ranging from spreadsheets to multi-million-dollar MES systems and laboratory information management systems. So with all of those systems in place, there's obviously a lot of communication and a lot of integration which has to go on. And what ISA95 does is define these as activity models and defines these as data objects. So ISA95 is implementation independent. It doesn't define exactly how these pieces integrate, but it does define a standard terminology for what these things are that go between level 4 and level 3, and the type of information that goes between level 3 that's in there. Now, one of the things that we realized as we looked at this was that the communications between level 3 and level 4 tend to be loosely coupled asynchronous processes, that they may be even occasionally disconnected. You may have a business level system which is corporate, which is on a different continent from your plant. So there may be disconnects and other things going on. ISA95, an implementation of ISA95 was done and is by Mesa, and it's called B2MML, Business to Manufacturing Markup Language. It's an XML-based exchange mechanism really designed for loosely coupled asynchronous processes. As you look within level 3, though, particularly at the lower level activities that we have down there, they're tightly coupled synchronous processes. You can assume that they're continuously connected, because if any of these processes stop, you tend to stop your production that's going on. That's the area where OPC and OPC UA really fit in, because it provides the high-speed connected communications that you may need at this level, and it then complements the work that had already gone on in ISA95 and the implementation in B2MML. So what we're talking about here today is that lower level, how do we implement some of these pieces of the ISA95 model. Now, it's not just production, even though that's the one I talk about mostly. It's also dealing with plant maintenance, quality management, and what ISA95 calls inventory management, but in actual fact that's things like warehouses, automated guided vehicle systems that are moving materials, tank farms, these sort of things. It's really managing the physical inventory of the facility. But each of those activity sets, and they're called categories in ISA95, has an equivalent set of activities that go on, and equivalent information which goes back and forth between the business level systems and the MES or MOM or LIMS systems that are down in level 3. And then these things also have to communicate. So for example, production and quality have to communicate. So there's information that flows each way. Now, just to give you some idea of what that information is and what some of the names are, what I've got here is a slide set that's showing some of these pieces here. It's showing the detailed scheduling, for example, activities communicate to dispatching, and they use an object called a work schedule. So we have a whole set of these information objects that go and can be used to integrate the different elements of level 3 together, as well as to integrate to level 3 and level 4. There's the ones over on the side. You'll see the process segment, physical asset, equipment, material, personnel. Those are the underlying pieces of information that really are used to make up the other pieces. So they're the underlying terminologies and dictionaries and words that you use inside your facility to do communications. Now, to make this all work in the ISA95, there's really two pieces of it. One is a very formal UML, Unified Modeling Language, model of the objects that need to be exchanged. So this is the information represented as objects. So computer science people really like this. Programmers really like this. And associated with each object model are a set of attributes. So each object has attributes, and they're very specifically defined. This is an exchange mechanism. So basically we're saying this is how you exchange the information. We're not saying this is how you architect your solution. We're simply saying this is in the exchange model. You take data from one of your systems, you put it into this format, and then the other systems can pull it out in an equivalent format. Now the pieces of the model that are there are listed here. The primary piece that we're looking at here are the resources on the bottom. This is really where the OPC UA will focus on, and Paul is going to focus in on those. We have a set of models that deal with the business view, which is basically the way that the business abstracts what goes on inside a plant. It doesn't see all the details. With the operations schedule and operations performance coming back, operations definition that defines things such as the bill of materials, and capabilities that says what you're capable of doing for rough cut scheduling. Operational views gives us the work schedules and the work definitions. Process segments are a way to collect all the resources, the physical asset, personnel, material together, so that we can describe them in these other top-level schedules. These are the models that sit in ISA95. Another way to look at these models is like this, a little bit more graphical, where we talk about equipment and we talk about physical assets. Now these are two different things. So when we talk about equipment in 95, we're talking about something called a role-based hierarchy or role-based equipment, so that a valve inside a system has a role, you know, valve 101. But it also has a physical asset, and usually a physical asset tag known by maintenance. If I were to replace that valve with a different valve, the role remains, but the physical asset changes. We realized that we needed both of those models in there to describe the things that go on inside a manufacturing facility, all the equipment and the role that that equipment is actually performing. So again, here's another list of the different object models that exist in ISA95. It's a rather rich set of lists of objects. Now, as we've looked at the OPC UA implementation of that, we really focused in on just a few of those object models, and we're going to talk some about those. Excuse me. One of those is the personnel information. So, for example, we have a person. A person is defined by 0 or more classes. Even though we use the term class inside an ISA95, it's really more of a role or a type. And each person has properties, each classes have properties. So, for example, we may have a class of operators, and the operator has a property that says whether or not they can work second shift. Each person then has a value for those properties that say, yes, this person can work second shift or not. Likewise, we have qualification tests and qualification test results. So these are the formal object models, the UML models that were used in creating the OPC UA 95 companion specification. And I'm going to switch over the presenter to Paul, and he's going to walk through the OPC UA specs. All right, Paul, you're on mute, I think.
Thank you, Dennis. Sorry, I didn't realize I was still muted. All right. What I'll go through here is what we actually did for OPC UA. One of the things Dennis mentioned already is that, OPC UA, why even are we doing it? Well, there's a B2ML transport, but it's an XML-based transport. It's really for the higher levels, 3 and 4. And what we realized when we looked at the 95 model is that it has applications down even in level 2, especially some parts of the model. So using OPC UA, it's a nice complement to B2ML in that we have a higher speed binary sort of base transport of information, and we can transmit it down in level 2 or even make use of it in level 2. So let's go through a little bit of what we did. So we have the same general models that Dennis showed, but what we did is we focused on the resource models. So the role-based equipment, physical assets, personnel, material handling. So these are the models that we transcribed into OPC UA. The models are based on the UML diagrams that Dennis was showing, but they sort of further enhance things. As part of it, when we were analyzing the models, we realized that there's a set of objects or set of types that are common to all of the models, whether they're personnel or physical assets. So when we built our UA model, we created an abstract set of types to base the system on. Since in OPC UA, our object model allows a hierarchy and allows us to inherit from parent types, we figured we'd make a structure that fits well into OPC UA and it models what 95 presents. So we built the base types, then we created the individual types for personnel, physical assets, equipment, material handling, based on that generic types. So part of this in 95 is that there's also quite a bit of information available. So it's not just objects, but the relationships between objects too. In OPC UA, you model relationships as references, that they provide semantic information about how objects are related to each other. So as part of the UA model, we created a fairly large, extensible list of references. And the references provide information. So, this object is assembled from these objects, or maybe it's equipment that's made up of other pieces of equipment, or what the test procedures are. So the actual references provide information related to the object model that you've created. So let's go through the individual models that we built. We built the personnel model. So as Dennis mentioned, personnel have different roles that they have in a plant. They're called classes, but they really are roles or functionality that they can fulfill. And they have testing that they've accomplished, qualifications, that they're certified to do this, or certified electrician, or maybe certified as a mechanic. The key thing is that there's different assignments that a person has, and one person may have more than one assignment. So we built a model that's based on the 95 model. It has a set of classes, personnel classes, that a person can have. Note, in OPC UA, we have inheritance, but it's from parent to children. There's no real multi-inheritance defined. It's just not defined. So part of what we built in this UA model is the ability to have a person type inherit things from personnel classes. So if this person is a certified electrician and a certified mechanic, then he would have two roles assigned to him, two classes, and the model would inherit the pieces from both. So this allows us to create the model the way 95 entailed it, and allow us to have the person with the appropriate testing and the appropriate qualifications, and it displays nicely. So we also did the equipment model. Equipment model is much the same from a class point of view. You have, higher level equipment that's comprised of other pieces of equipment. You also have equipment that has different functionality. So in this case, what we're showing here is maybe heating reactors versus mixing reactors versus reactors that have both. And they have different properties available. So we built a model that allows us to do this. So the equipment classes, again, the equipment properties, we have test results for them, and you can build a reactor that has the appropriate properties and appropriate constructs based on the classes that are available. So as we're going through, well, I wanted to have a quick reminder, since I'm in the middle of my sort of section. If you have questions, please ask your questions. So let's go on to physical assets. So Dennis mentioned what a role-based equipment was. So it's the logical representation of a piece of equipment, really. So it's, a transmitter or a sensor in the plant. Now, this role-based equipment is represented by some physical asset, but you may move the physical asset. It needs maintenance. You have to take it out and replace it with a different one. But the equipment stays the same. The same functionality is available there, even if you move that sensor to a different place or you've taken it out. So that's why there's two models. There's the physical model and the role-based equipment. So if I'm looking back at a pressure, I don't care which sensor provided the pressure. I just want to see the pressure. So that equipment stays the same throughout the life of the process. The physical asset, though, maybe has to be taken out for maintenance. Maybe it's put back in a different place in the plant. And sometimes it's worthwhile to track that because maybe that physical asset has an issue, and you can determine it from the fact that hey, every time I put this in the plant, it lasts 3 weeks, then I need to go perform some maintenance on it. So the key thing here is that there are two different models, and they're very useful together. Again, this model looks a lot like the equipment model. There's a set of classes for grouping the equipment functionality, then there's actual types of equipment, and then you create instances of the types. You have testing available for them. For the classes, typically for physical asset classes, they have standard properties like manufacturing and model number, so some standard information that all physical assets would have associated with them. So the last model we built was the material handling model. This is a little more complex model because it has more information to it. Physical assets are things that sit in plants and they stay there. Material handling is for the items that move through the plant. So I have raw material coming in, I do something to it, I create it into a widget, and then the widgets get palletized or put in boxes, and then they get grouped with lots, and then they get shipped out. Maybe they get tested on the lot, if you're making a batch of chemicals. The key thing here is that there's a bit more to the material handling aspect of it. But from this is where you get how much of something did I make and what was the raw materials that I used to create it. So we built the UA model, again, based on the 95 spec for material handling. It has all of the basic properties and information for the type of material that you're building. But there's also definitions for what the base material should look like. There's lot information for each lot that was processed through the system. So the lots come and go as you build systems up. You have, of course, a class of material that you're making, and they have the same inheritance and the same sort of functionality available. So we have a fairly complex material handling capability built in. So this is what the OPC UA models generated. And from these models, we had a fairly complete resource model for OPC UA. But then when we looked at the B2ML transport, since we wanted to be able to transport the same information around, the 95 spec is an abstract spec, as Dennis said. It doesn't really describe data types or information. In OPC UA, there's a fairly complex capability of defining actual data and what the data looks like. So it's ints, it's floats, maybe it's a structured value, maybe it's a fairly complex piece of information. B2ML has similar capabilities, but their representation of the data is a little different. They actually can add attributes to the description of the data. So we want to be able to transmit that additional data that B2ML may provide. So we generated some new data types and some supplemental data types that allow us to include some of the additional data that was used in B2ML. But it really gives us a full model for the OPC UA 95 model. It lets us have a complete system that provides both the benefits of UA, so the faster transports, the the complete information modeling. It lets us link it to other information models you may have from other or companion specifications. It lets us have the same data that we can have in B2ML and transmit it around. Now, it complements B2ML because the B2ML transport is there, and there are a number of systems, especially level 4, that are expecting the data through a batch process in XML. That isn't the goal of this. This is more from the lower level system 2s. We have a specification. It's been released. It's been released for a number of years, actually. In the future, we're working on a new version of the spec, but it's not so much new. It's more that the IEC wants to have the specification released as an IEC version. Note, all the existing base OPC UA specs are available as IEC specs. We just want to add this one into the grouping of IEC specs too. So it'll be released as an IEC spec, and we're working on that now. There are implementations. There's a sample implementation that the foundation provides, but there are other vendors that have samples too. And that's what we're going to hear a little bit about. We're going to go to Rich, and Rich will provide a description and example of what they've done. Rich?
Thanks, Paul. A screen shown. So Capstone has two product lines, Data Park, which is process visualization and analysis, making heavy use of trends and graphics, and Convergence, which is learning management systems and computer-based training modules. Oftentimes the training modules are on equipment that we have process analysis on. So a few years ago, we'd started planning our migration from classic OPC to UA, and we saw a need for something like an ACID framework. The ISA95 companion spec was released around then, and it met our need. It was already building on top of UA, which is the direction we were headed, so that was a good thing. And it has something that both of our products can benefit from. So our ISA95 implementation of the pieces in the model, we're working on equipment and physical assets currently, and personnel are in the next phase. The server that we're building is the migration of our HDA server to UA, and at the same time implementing the companion spec. So on the UA front, we mapped our existing process tags to subtypes of the UA data item type. We're leveraging views, which are a construct in UA, and that allows us to organize our multiple hierarchies and gives us reuse of the nodes. Some of the hierarchies that we're implementing are equipment, logbooks, our process areas, and some others as well. Our implementation of views, and a view can be a server-defined look into the address space, but our implementation is using reference types to differentiate what belongs to which view. And then we created objects and variables and references to support the requirements of our existing product. And I'm going to move into the demo now. The demo is pre-release, and not all functionality is there. One thing that is not there is the add edit capability, so I'm not going to try to add any piece of equipment. So this is our browser view. It's fairly typical of what you would see in a UA browser, where you can browse the UA hierarchy. And when you click on a given node over on the right-hand side, it shows attributes and references for that node. So again, that's pretty standard UA work. What it also shows, though, is that we've got our collection of views listed here, and we'll get into those more in just a little bit. But each of these represents the slice of the address space that we want to represent for a given concept like logbooks or a physical hierarchy. So in the ISA95 model, let me pull up another browser here. If we go down through the type hierarchy and go find the ISA95 base object type, equipment type, this is the point where all equipment is defined, or all equipment is subtyped from. So this matches where we start our equipment definitions. And if we click on one definition like motor type, it has these properties. And in this column called defined by, you can see where those properties come from. So you can see equipment ID comes down from the top level, but these other properties like frame and horsepower are related to the motor only. So you can further subtype types and add in additional properties, and the list just keeps on growing. And once again, it shows where they come from. Once you have your types defined, you can go start creating instances. And if we go look at the instances of the AC motor type, you'll see the properties that were shown back on the type definition. As you pick different types, because they have different properties, the columns will change. So for this view, what we're doing is a pivot of the properties to get them in the columns where you would expect to see them for maintenance of equipment. At this point, we also start to see where you can tie in the process information from our server. So these values, as you can see, can be static, or we can drive them with values from a process tag. So if I bring up our tag browser and pick a process and find the tags for one of these control loops, you can see this is the process variable for that control loop, and this is the condenser water flow. Oops, let me see if I can get this right. So dropping that tag onto that property adds a reference on our server, and then when you go to read the value for that property, it'll be driven from the HDA server, so essentially from the field device, so you'll get real-time data there. So you can fill the rest of these in. And so that's created the references and told the server to start serving up the actual values for those. The physical assets, the types and the instances work much the same as what we just saw for equipment. the properties will be a little bit different because the motors, for example, on a physical asset, you'll be looking at the nameplate ratings here in the physical asset, and you probably won't have any tags associated with the physical asset. But back on the equipment, you'll be looking at the spec for that position, and you most likely will have tags associated with that. So moving on to our hierarchies. These are the main things that we're concerned with building hierarchies. For example, logbooks. Our logbook product allows you to record notes and comments and operator issues against something, and so we had a hierarchy that was built just for maintaining that, and it pretty closely matched the physical layout of the mill. We have this hierarchy, which we're calling physical, which is the ISA95 equipment and physical assets, and should probably pretty closely match what you have out there in the facility. So what we do with these two nodes, or two views I should say, is that we open a new window. We can start manipulating nodes to get the actions that we want. So here under physical, first thing I'm going to show is moving a physical asset into a piece of equipment. So this again represents the piece of equipment, and if we come over here and pick a motor, we can drag the motor and drop it on that piece of equipment, and that creates the reference on the server to assign those to, which is a ISA95 implemented by reference. And also ISA95 also has a variable and a data type for tracking that movement. So when you do that drop, it will record that it was moved from wherever it was into that position at that time. So the other thing that you can do with the hierarchies is you can drag between them. And as I mentioned before, the logbooks is our hierarchy for recording information. But now what we can do is we have this evaporator node, which is a ISA95 piece of equipment, and we can drag it over and drop it in the logbook hierarchy, and it picks up the characteristics of that hierarchy. So now that piece of equipment has a logbook associated with it. It doesn't bring along all of its children from the previous hierarchy, so that gives you the flexibility to set up slightly different or totally different hierarchies, but still have the same set of nodes. So this evaporator node can be queried for both equipment information and logbooks, or whatever else you set up a hierarchy for. With the structure of the ISA95 that we've built up, you can get a lot of information about the equipment. So if you click on a node, you can pull up a safety video that we've linked to it. Or if you have a maintenance system and you can query into that maintenance system, we can run a SQL query or another type of query against the maintenance system. using the equipment ID, which would be common between the two systems, to retrieve the data for the user. And you can also open our trend from here. So you can drill down through the hierarchy and start troubleshooting. So most people are not going to start their day working in the hierarchy. They'll probably be working on the trends. So I'm going to pull up our Park View application and open a trend. So an operator might be looking at this trend and see a problem and want to investigate it, and he pops out a larger trend, sees something that leads him to believe that work might have been done or something might have happened. So he can right-click on here and bring up an asset information pop-up. And what that pop-up or what that menu selection did was go to the asset, the ISA95 framework, and query where this tag was used. So there's one section here for each of the 3 tags on the trend. And we want to see what the PV set point and output of that particular line was. So we click on that first one and it shows up behind. So you can now see the PV set point and output in one spot, and mode should be there also, but I didn't have it in the demo system. One thing you can do from that point is you can go launch loop tuning or other applications to do analysis on your loop health. You can also get to the same things that have been defined in the asset framework from this point of view. So you get back to your work orders or anything that's stored in the asset framework is available. And lastly, we're getting more and more into process graphics, and people find that as a very useful tool for troubleshooting, getting a good handle on the mill, how things are going. So we are making this connected to the UA server as well. And let me see if I can bring up my UA server. So for this demo, this move I'm going to do is going to go into discharge pump 1B motor. So this is where the motor is going to land. The text isn't right for what I'm showing you on the other screen, but that's what the demo is wired up to do. So as you can see, there's nothing in that spot right now. So I'm going to take this motor out of motor storage and drop it here, and the gray box represents the equipment itself. And so I just moved a physical asset into a piece of equipment. And now if I reload the children, that motor shows up there. And once again, the reference has been added on the server, the record created in the transaction table for that move. So I think that pretty well covers our implementation. I'll turn it back over to Paul.
Thank you, Rich. It's a very excellent demo. I never get tired of seeing your demo. Let's go through and at this point in time, I'll give you a little summary. What we heard from Dennis was a very nice summary of ISA95 and an overview of it. I went through the models that we implemented in UA and where they stand and how they complement the ISA95 implementation, well, I should say the B2ML implementation of ISA95, and how they provide a nice real-world way of transmitting information in real time. And then we saw Rich's nice demo of a system that's actually implemented the 95 model and provides it. I think, Dennis, do you have something more to add, maybe?
Yeah, just a few points. You know, one of these, as I mentioned before, the ISA95 standard is an implementation independent and an abstract model. It takes implementations of that. What we found when we were doing the B2MML was that it worked really well when we're talking to business level systems, when we're talking about transaction rates that can be measured in minutes, you know, or multiples of seconds, but it doesn't work real well at high speeds. What I view the OPC UA 95 companion spec is a way to get the speed matching that we currently have. If you're within level 3 systems, you could be hitting your business level system with thousands of requests every minute, which would just completely swamp most ERP systems. With the ISA 95 OPC UA model in there, you could be using OPC UA to collect information from a localized server, from a localized cache, and doing it in real time, so you don't basically slow your process down in order to get data. So it really complements the existing definitions we have. Another really nice thing about the OPC UA 95 specification is it's really going to help us in the industrial Internet of Things, the IIoT world. There are a lot of companies, there are a lot of organizations out there right now looking at using OPC UA as one of the communications or primary communication mechanisms in the industrial Internet of Things, which is basically where every device we have out there is smart. Every device has computing power in it. And with the OPC UA 95 specification implemented, each device itself can be self-describing. You can say, I am this type model, I am this product code, this model, here's my parameters, here's my base level horsepower, here's what my real-time values are. So I think the OPC UA really helps us move forward in the industrial Internet of Things, more so than what we have today. It's definitely going to help us today as we're building data servers because we're talking to devices that aren't smart. And in the future, as these devices get smart, they're going to be self-describing. They'll use these protocols and these data models to communicate to the rest of the world that's out there. So I think we're at the beginning of something here. I think we've been able to implement this. Paul has done a fantastic job. Rich has done a fantastic job to get these models implemented using the OPC UA terminology, methodology, and communication stack. So thank you, Paul.
Thank you, Dennis. So with that, we're pretty much done with our presentation. It's time for questions, and we do have a few questions, but if you have some more, please feel free to add them. I think the first question that we have to answer that we should have mentioned, and I'm sorry I forgot to at the beginning, is how you can get a copy of both the recording and or the specs, or sorry, the recording and or the slide decks. You know, I may let Tom answer that question. Tom?
Thank you, Paul. My name is Tom Burke, and I'm the president of the OPC Foundation. And actually, there's two things I want to do. One, I wanted to thank Dennis, Paul, and Rich for taking time out and actually presenting this very informative webinar. And also thank the audience for taking time out from their busy day to attend the webinar. The copies of the presentations will be available as a download from the Foundation website. We'll also send a link out to all those that have registered for this webinar. And also a copy of the recording will also be available and on the Foundation website via our YouTube channel. And we'll send you out a link to that as well.
Thank you, Tom. So I see another question that we have is the spec available? Yes, and I'll answer that one. The ISA95 OPC UA companion spec is available. You can download it from the OPC Foundation website. And It is not a part of the ISA95 group of specs, so you won't see a link to it from there. Dennis, I think you mentioned before that you may be available through the MESA.
Yeah, what we'll try to do is what I'll work on is to get the B2MML site updated to give us a link to the OPC UA spec, because I believe these two complement each other. So that if you get to one, you should be able to then get to the other.
Yeah, I think we'll make sure that the links work in both directions too. I think I see another question here. Can the browser pack manager be downloadable? So are you asking for, I'm not sure if this person's asking for a sample of the demo software or not. I don't know, Rich, I'll leave that to you to answer if you have demo versions of that.
It is not. It is still in demo, or I'm sorry, still in development, and we don't have a downloadable version.
Okay. Now I check back with Rich maybe in the future, right, Rich?
Yes.
Okay. I have another question here for, I guess it was referring to motor types, and are they part of the ISA95 standard from the demonstration? Rich, do you want to answer that, or is that something you're okay with?
Yes. So the motor types that I showed were not defined by the ISA95 spec. They were derived from equipment type, which is defined by the ISA95 spec. So that particular motor type is our own implementation.
Yeah, that's what we expect from people, is that the 95 spec is abstract spec. It defines equipment and physical assets. The UA implementation of it is also abstract. We expect vendors and end users to define their own instances, their own classes that create the individual pieces of equipment, but it's a framework from which to build those equipment so that they have a standard way of exchanging and a way of showing relationships.
Yes, and one of the other activities that's going on currently in the ISA95 Standards Committee, as I said, it's under continual development, is really the definition of profiles. And we're hoping that we can come up with standard profiles per industry segment that would define the properties and the classes and standard names for these things that could be used. And then I can easily imagine that in the future we'll take these ISA95 profile models that are developed for specific industries and then implement them as specific profiles, again under OPC UA, the UA 95 spec profiles underneath them, to show how those things are mapped into each other. So it's not that that's not a problem. It is a problem, and there are people working on that problem, and I encourage anybody who would like to help work on that to participate in the ISA95 efforts and or the OPC efforts to actually make this happen.
Yeah, the OPC UA working group is always interested in people that want to implement something and are interested in extending a companion standard. So, we did the resource models. If there's some demand, we can move up and do some of the higher level models. The resource models are the ones we implemented to start with because they fit level 2 quite well. And the actual mappings for standard industry standard sort of vertical mappings is something that we're looking forward to adding when they become available, because I think they'll be a good fit for what we have. I'm looking through the list of questions to see if I have anything more. Bear with me a second. There are lots of questions, but many of you asked the same questions. I think there's a question about, this must be someone that's working with OPC UA, actually, because there's a question about how this will fit into our new pub submodel we're working on. We haven't integrated those models yet. The pub submodel is still in progress, but the information available in this model, you should be able to transmit through the pub sub model too. So for the smaller embedded devices that want to add a UA and want to be able to just publish data, they can make use of this model too. and publish the data that's in this model. The pub/sub model is just adding additional transports. So that should have, no effect on what the data is. So we can easily transmit this data too through that new incoming OPC UA feature. I think we're getting near the end of our time. So unless anybody has an urgent question yet, you can always email us and we will provide additional help and answers. With that, I think I'd like to end the webinar. And thank you everybody for attending. Thank you, Tom, for the nice introductions. Thank you, Dennis. Thank you, Rich, for your contributions to the presentations. Thank you all for attending and spending your day with us.